Welcome to today's Explainer. We're taking a really fascinating turn today. Up until now, we've focused heavily on the properties of gemstones from a largely conceptual standpoint, the theory. But today, we're shifting gears from consumer-level knowledge to a true behind-the-scenes toolkit tour of the professional gemology lab. So let's just dive right in, because this is where the magic really happens. Like this quote says, everything we've learned so far was theory. Today, we walk into the lab and show you the actual instruments. I mean, think about it. Things like refractive index, birefringence, pleochroism, all of that is essential vocabulary, sure, but it's totally invisible until you use the right tools to measure it in real time. Today, we're stepping into the lab to show you exactly how gemologists turn that vocabulary into hard, undeniable evidence. Okay, so here's our roadmap for the lab tour today. We'll be looking at theory meets the lab, the refractometer and polariscope, the dichroscope and spectroscope, the gemological microscope, and finally, the layered process. Section 1, Theory Meets the Lab, from vocabulary to hard evidence. You see, this explainer is all about demystifying that lab environment. To the naked eye, a beautiful red stone might just look like, well, a beautiful red stone. But what you can't see is exactly what gemologists are trained to see. Using specialized equipment, they look right past that surface beauty and actually measure the invisible physical and optical properties that define the stone's true identity. It's like having X-ray vision for gems. Section 2, Refractometer and Polariscope, Bending Light. First up on our tour is the refractometer. This incredibly clever device uses a high-RI glass hemicylinder to directly measure a gemstone's refractive index on a calibrated scale. Basically, the gemologist carefully places the stone onto this hemicylinder, and as light passes through it, they can read the exact refractive index value straight off a scale inside the viewer. It's that direct. Let's take the number 2.42 for example. For example, if you recall our earlier discussions, this is the refractive index of a diamond. Fun fact, it's actually this exact, massively high number that gives diamonds their signature aggressive sparkle. And this isn't just a theoretical number pulled from some textbook, right? It comes directly from exactly this kind of refractometer measurement in the lab. This is literally hard evidence in action. Next up is the Polariscope. This is a tool that uses two polarizing filters to determine if a stone is singly or doubly refractive and to detect internal strain. So while the refractometer measures the angle of light, the polariscope is investigating a stone's internal optical structure. The gemologist basically just observes how the stone reacts as it's turned between these filters. It's so cool because the polariscope literally forces a stone to declare its identity. Is it singly refractive or is it doubly refractive? Meaning, does it split light into two separate rays or keep it as one? And beyond just refraction, the polariscope is absolutely crucial for revealing internal strain patterns. These hidden strain patterns are incredibly useful clues for distinguishing a natural, earth-mined gemstone from certain synthetic materials grown in a lab. Moving on to Section 3. Dichroscope and spectroscope, splitting colors. Now, the dichroscope is a fantastic little tool. It's a small handheld instrument that splits light into two channels to let a gemologist directly observe pleochroism. It acts almost like a magical little window. Why does this matter? Because it lets you see that fascinating color shifting effect we've talked about with stones like tanzanite. The real beauty of the dichroscope is that you can see these different colors side by side all at once without having to physically rotate the stone through multiple viewing angles. Such a time saver! Then we have the spectroscope, which ties directly back to the principles of color chemistry. This is an instrument that reveals a stone's absorption spectrum to show exactly which specific wavelengths of light a gem absorbs. Basically, it shows us exactly which wavelengths it's absorbing and which ones it's letting through. Because certain trace elements inside the gem produce very specific, highly repeatable absorption patterns, a spectroscope helps confirm or rule out particular colorants. Honestly, it's like reading a barcode that tells you exactly what elements are creating the gem's color. Section 4, the gemological microscope, inside the stone. Now, arguably the most versatile tool in the entire gemological lab is the gemological microscope. This is a versatile magnification tool used to deeply examine the internal inclusions within a gemstone. We're no longer just looking at light passing through the stone, right? We are going inside the stone itself. It takes us straight into the hidden world within the gem to look at inclusions. And as we've learned, inclusions aren't just flaws. They are the ultimate fingerprints of a gemstone. They tell a story that literally no other property can fully articulate. So what exactly can inclusions reveal? Well, looking closely through the microscope can instantly reveal a wealth of information all at once. By examining these tiny internal features, a gemologist can often determine the geographic origin, meaning exactly where in the world the stone was mined. They can also definitively tell if the stone is of natural origin or if it was grown in a lab as a synthetic. And crucially, inclusions can reveal the stone's treatment history, showing if it's been artificially enhanced. Section 5. The layered identification process. Building the case. Let's take a second to summarize our toolkit here. Every distinct instrument gathers a specific, isolated clue, tying directly back to those physical properties. The refractometer gives us the refractive index. The Polariscope checks for single or double refraction and internal strain. The dichroscope isolates pleochroism. The spectroscope reads the absorption spectrum. And, of course, the microscope reveals those all-important inclusions. It's like a giant puzzle coming together. Because you see, professional gem identification is heavily reliant on this combined evidence. It's a layered process. The gemologist has to act like a highly skilled detective following a very strict workflow. Step 1, measure the refractive index. Step 2, test the optical character and color chemistry. Step 3, deeply examine the inclusions. And Step 4, absolutely the most important step, cross-reference all of this data. A reliable identification requires overlapping confirmation from multiple tests to absolutely guarantee what a stone is. We completely rely on this meticulous, layered process to protect the integrity of the gem trade. But that leaves us with a massive, looming question for our next step in this journey. What happens when these instruments reveal a stone has been artificially altered? What happens when this rigorous cross-referencing proves that a stone isn't entirely natural? Whether that's through intense heat treatments, fracture filling, radiation, or diffusion. Well, that is a whole new layer of complexity, and we'll definitely have to explore those deep dive treatments very soon.